Hi there, this is chapter 23. So first we find the course notes for chapter 23. On this list, you probably won't see chapter 23, and you need to click load more to show 2 more chapters notes. And we continue with chapter 23 Inference for Regression. So in this chapter, we will use this example, body fat and the waist size as an example, and we will talk about the assumptions and conditions checkouts, and then in the last portion we will do some 95% confidence interval on the slope, confidence interval for predictions, so that's a confidence interval for a mean value, and individual, this is called the prediction interval for individual values. Let's take a look at this example. I already copied the data into this Excel file. And this one has a waist size, weight, and percentage body fats. So make sure which value is your Y value, which one is the X value. So there's many mistakes in the assignments, also even in the exams. So in this case, we want to look, in this example, we want to look at associations between the percentage body fat with the waist size. Remember in Excel, once we do the scatter plots, this is X value, this is Y value. Once we select X value and then use Control and then select this Y value, we will get this scatter plots, and then we try to show the trend line and then trend line equations and R-square values. So this is we taught in chapter 7, and then this video will use another tools. So remember we have this data analyze tool. So click data analyze tool. We use regression analyze. So find the regression analyze and then click OK. And in this case, we select input Y range. So that's the Y value is this columns, and then goes to input X range. So we want to see these two associations. So click label because our first row is the label, and the confidence level is 95%. And also we want to use a new worksheet, give us the output, and then the residue as the options we need select all 4 options for the residue analyze, and then there is normal probability plots. We can click this one, just take a look at this one. So this is the new this is the output values from that regression analyze. Just give some bigger space for each column, and continue with this one. Continue this one. We will talk about each individual column's meaning. Okay, and also it will provide us 3 figures. The 3 figures is basically, this one is called the waist size residue plots. This is you can see the x-axis is still our X value of waist size, and y-axis provides the residue plots. I just expanded those plots, and then we double click these plots. We want to change, so you probably see the data is shown in this region, and we just make some changes to show these points, these data points in the whole region. Okay, so I made some changes. So the x values, x-axis values, we set the minimum 30. So it will give us this display. And also I can move this one to... So I have moved the labels to the bottom so we can see the pictures on those dots more clearly. And this is called waist size residue plots. And this one waist size line fit plots. So I already changed some formats, show the trade line for the percentage body fat, and also give us the equations, linear equations, and R-square value. You look at these equations, it will give us exactly the same one if we use the scatter plots to get the linear association. So these two should be exactly matched. So this is basic give us the linear association. And also the normal probability plots. So the normal probability plots, make sure to see this one is sample percentile, and then percentage body fats. So that's basically is this table. We get the probability plots of the percentile. This is the value you probably see in our normal probability plots. This is 0.025, 0.075, those values. This is just multiplied by 100, give us the percentile. And the body fat is actually our Y value. So this is basically the normal probability plot for the Y data. So let's go back to the notes. Let's check how many what conditions we need to check. So first, there's assumptions and conditions check. There's 4 conditions we need to check. First, linearity assumptions. That's basically from our scatter plot with the fitted line. It should be closer to this line. So those data points should be fit to these lines. Then we see it fit the linearity assumption. And the second one is independence assumption. We want to see the residue plots. So that's those residue values must be random. So that's meet the random condition. And also the third condition is the equal variance assumption. In those residues, the values of the positive and negative residue should be approximately equal, and there's no patterns in these plots. And let's take a look at that question output. So this is basically we don't have the residue fit plots, but this one is quite similar. So this one is with the points is almost random, and the positive negative is quite similar. So it's fit the equal variance assumptions and no patterns in this one. And next condition is we want to see the normal population assumptions. In this question, in this condition, we want to check near normal condition for the residues, not the data values. So remember, another condition is outlier condition. We will check in Excel. So in the distribution of the residue should be unimodal and symmetric. That's the required condition. Let's go back to this one. As we talk about, this one gave us those. Now we want to check the residues meet the near normal condition. In the outputs, you can see we have residue output table, and you will see this is predicted about percentage body fat. This is residue actual data subtract with this one. We get the residues, and this is standard residue. And then so this normal probability plot is not our residue normal probability plots. So how we do the residue normal probability plots. So there's an easy way to do the residue normal probability plots since we have this output reports. So we do the copy this residue, Control C over this column, and try this one, and we do the copy, select this copy, the second one with 1, 2, 3 here is basically we will copy the values only. So on this columns we only copy the values, and because we need to sort those values, so I just change the values on this column so it's blue. So now we want to sort it, so change this into sorted residue. So remember how to sort this one. At home we have sort, so that's basically we will sort from smallest to largest, and then continue with the current selection. So this is a sort those residue values. So you see we copy the values here, so we can sort those values without affecting the original residue output. Remember this one is actually associated with equations, so we cannot sort these columns, but we can sort these columns. And now we draw the normal probability plots with sorted residue. Remember before we have a probability of each data. Here we just select this percentile. So we just talk about this percentile is those probabilities just converted into percentile. So use this one, insert scatter plots. And simple way of this one is we do trade line. And I also commonly will ask you to show the R-square value. Okay. Now just change this one into MPP for residue. So this is the MPP for residues. Another one is a box plots. We put both together and then compare with our nodes. So box plots. Residue box plot. So from this box plots, so normally what we will do is we try to see if there is any outliers. So this one shows we don't have outliers at all. And then this is normal probability plots for the residue, and these values also those data points is very close to the these diagonal lines. So that's we see quite good to fit this near normal condition. Let's go back to the nodes. So that's basically we use the box plot check there is no outliers, and also near normal condition we check this one using the normal probability plots. That shows quite a similar figure in the Excel outputs. And this one is we usually do not do the histograms for small data sets because the small data sets does not really show the unimodal and symmetric pattern. Let's take a look back. This is the I did in previous same outputs. That's the residues histograms does not really useful for small data sets. So this is the 4 conditions we need to check for the assumptions and conditions check out. And following is the we need to do is the confidence interval. So there is the 90% confidence interval for the slope. So that's for the slope. In this condition, we in the notes we calculate this one. This is because Minitab does not provide this function, but Excel has these values provided. Remember, this 95% confidence interval on the slope of B1 is between 1.648 and 2.796. Let's look at Excel's outputs. So this is the Excel's output. We just see this one. Go back to here. We already talked about this is the summary output. There's multiple R square, and then standard errors observations. So that's the residue standard error, and observations in the sample size is 20. And another one is this intercept coefficient. That's a B0. With the size is basically the slope, so B1. So this is the coefficient, B1 coefficient, and B1's standard error is this one. This is standard error for B0. That's the intercept. And another 2 values normally we will ask is the T statistic value. So that's most common. We use this B1's T test value is 8.14, and the P value of this T associated with this T is 1.899 times 10 to the power negative 7. You probably see this value is matched with this one. So make sure in the questions sometimes we ask you the test statistics is T value. If the question asks you F value, that's the F value, but the P value is the same. And remember, we talk about the 95% confidence interval. We just talk about is these 2 values for the B1, 1.648 and 2.795. That's the 2 value. It's the confidence interval for the B1. 95% confidence interval for the B1. And continue with the notes. We have more on this one is we want to do the confidence interval for a mean value Y, for a fixed X value, and also we have prediction interval for this is for individual given X value predict the individual Y value. This is to say we have another data sets, and for fixed for a given X value, we want to predict that data set's mean value in which range. So this one, the Excel does not provide us this function. That's why we need the templates. I designed the templates for regression model prediction of the confidence interval and prediction interval. So that's a regression prediction confidence interval prediction interval templates. And let's take a look of how we fill this table, and then we get these 2 values from this one and from this one. Just show both values here. Just see how we fill these templates. So first, the observations sample size is 20. In your report, we fill this observations 20, and then standard error is the residues. Standard error is this value. 4.5396998, and the intercept coefficient is the B0. 0. Intercept coefficient negative 62.557, and then the intercept standard error is 10.15767. Width size, the B1 slope coefficient is 2.22152, and the standard error is 0.2727887. And then these two values, we needed to input those two values. These two values is a simple way to get this one is from our original data. We just get the average value of this column and get average value of this columns. Remember, this is x, but mean value of x, this is mean value of y. So fill in these two values, 37.05, 19.75. And then the predicted value, so let's insert the either a mean value or individual x value. In the example, we use 38. We want to predict the 38 as our input value, given x or the x bar is 38, and alpha value is 0.05. And then predicted value corresponding to this 38, our y value, so you can see this is x value, and predicted y value is 21.86. And so that's the predicted y value, and then that's two intermediate calculation values used for calculate this prediction, mean prediction CI and individual prediction PI. So that's the corresponding to this given 38. The mean value prediction is between 19.659, 24.06. These two values is around this value. And if this one is given the individual prediction, individual person's width size is 38, and the individual prediction will be wider because this is only one sample. So 12.07 to 31.65. And we just go back to check with our notes. So you can see this is the confidence interval for the predicting the mean value. That's between 19.66, 24.06, and the prediction for individual is 12.07 and 31.65. That's basically match with our Excel output. That's all for these chapters, and thank you and bye.